Hey students, this is lesson 3A. In this lesson we are going to learn how to relate slope to parallel and perpendicular lines. Go ahead and do the review. I'll check back with you. All right, here's the key concepts for the lesson. If one of the key concepts, if two non-vertical lines are parallel, then their slopes are equal. And if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. Any two vertical lines or horizontal lines are considered parallel. So in this problem, we want to see if the lines in the graph are parallel. And they appear to be parallel, but to make sure, we're going to use slopes. So let's call this line A and this line B. And then what we'll do is just find the slope of each line, and if they're the same slopes, then they're parallel. So the slope of line A, we're going to take 3 minus -5 and divide that by 1 minus -3. And that's 8 divided by 4, which is 2. And then the slope of line B, we're going to do 4 minus -2 and 5 minus 2. And that's 6 divided by 3, which is also equal to 2. And since the slopes are equal, we're going to say yes, these two lines are parallel. All right, you can try that. Okay, problem 2, writing equations of parallel lines. What is the equation in slope-intercept form for the line parallel to y equals 4x minus 2 that contains the point -2, -2? Well, if we know that the line is parallel, that means it has the same slope as this line. So we can use that slope in our other equation. And then we just have to make sure that that equation works with the point -2, -2. So in slope-intercept form, here's our general form. And we know the slope is 4 to be parallel. So then I just have to figure out what the y-intercept is. And since it has to work for this point, I can just substitute -2 for y and -2 for x. And then figure out what b makes that true. And so we get -2 equals -8 plus b. Adding 8 to both sides gives us 6 for b. So the equation is y equals 4x plus 6. All right, I'll let you try that. All right, another key concept, slopes of perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is -1. If the slopes of two lines have a product of -1, then the lines are perpendicular. And any horizontal line and vertical line are perpendicular. Go ahead and answer these two questions. All right, problem 3. Are the lines shown in the graph perpendicular? Explain. If they are, then the slopes of the lines, the product of the slopes of the line should be -1. So let's find the two slopes. Again, let's label this A and this B. Then if we find the slope of line A, we do 4 minus 1 and divide that by 2 minus -4. And that gives us 3/6, which is 1/2. And the slope of line B is 5 minus -4 divided by -2 minus 1. And that's 9 divided by -3, which is -3. And if I multiply the two slopes together, if these two lines are perpendicular, then that should equal -1. And it's -1.5, so these two lines are not perpendicular. Go ahead and try this problem. All right, problem 4. What is the equation in slope-intercept form for the line perpendicular to y equals 3x plus 2 that contains the point 62? Well, if the line is perpendicular, then the slopes are opposite reciprocals. So we have to think of what is the opposite reciprocal of 3, and that would be the slope of the perpendicular line is -1/3. So I'm going to put that in for my slope. And now I just need to find the y-intercept so that the point contains a point. The line contains 0.62. So I'm going to substitute 2 for y and 6 for x. And then solve it for b to find out what that value is. -1/3 times 6 is -2. Add 2 to both sides gives me 4 for b. So my equation is y equals -1/3 x plus 4. The next problem, what is an equation for the line perpendicular to the one that contains 5, -1? So in this problem, I actually have to find the slope first of the line that I'm given. So I'm going to subtract the y values and subtract the x values and divide them to find the slope. And that's 5/2. And so the slope of the line that's perpendicular to that is the opposite reciprocal, so -2/5. And now I can write the equation. Since it doesn't say what form we want this equation in, let's just use point slope form. So y minus y1 is equal to slope times quantity x minus x1. And I can substitute for the slope, -2/5. And I can substitute for the x value and y value, this point here. 5 for x, -1 for y. And then I'll just simplify that. All right, you try it. All right, the last problem, writing equation for a line. So the baseball field shown below is on a coordinate grid with home plate at the origin. The batter hits the ground ball along the line shown. The player at 170 runs along the path perpendicular to the path of the baseball. What is the equation of the line on which the player runs? So the ball is coming this way, and the player is going to run this way to get the ball. And so in order to find the path that the player will be on, we need to know the slope of the line that the ball is on. And I'm just going to use a couple points from the graph to get that. And I'll just use rise and run for the slope here. So I'm going up 20 and over 60. So the slope is 20 over 60, which simplifies to 1/3. And so now I'm going to just use the point slope form to come up with the equation. Y minus y1 is equal to the slope times quantity x minus x1. And I'm going to substitute the position the player is at for my x and y value. So y minus 70 is equal to 1/3 times quantity x minus 1/10. All right, you try that using the same grid. Do this problem 5.
check and see you next time.